Good day, students. In this video, we'll learn how to solve the problems based on unique combinations of alpha and beta. So, so far we have completed all the basics. Polynomial division is pending, which we will see soon. Presently, we are working on sample and board problems around zeros and coefficients based on quadratic equations. So, if you have directly landed in this video, kindly check the video 7 on zero of polynomial as well as 9 on zero of quadratic equation to understand these problems. Otherwise, you will find difficulty in understanding. So far in the previous video, we have studied around 6 patterns of problems which can be asked. So this is the 7th pattern where you need to identify a unique combination of alpha and beta. So what does the problem give? The problem will give you a polynomial equation, or they might give you a summand product of zeros. If they give you a polynomial equation, you can find the summand product of the zeros. What you need to find out is, or you need to solve is, some unique combination of alpha and beta, like alpha square plus beta square, alpha minus beta whole square, 1 by alpha plus 1 by beta, which is again nothing but alpha to the power of minus 1 plus beta to the power of minus 1. If suppose instead of sum and product, if alpha and beta values are given, you can straight away calculate this easily. You can square the value of alpha, square the value of beta, and you can find it. But what you have is the sum and product. So how to solve this? So we'll this such type of problems here and there come in a few sample papers. I think I saw 2 or 3 instances. This is one sample where you can see they have given a quadratic equation and they are asking you to find alpha square plus beta square, then alpha minus 1 and beta power minus 1. Similarly, in a question bank, from a question bank I found out, this was a very old problem, 2007. They have asked you to find out every combination, alpha square, beta square, alpha minus beta whole square, alpha square plus beta square. I think this is a repetition actually. Maybe this should have been minus or something. Then 1 by alpha square plus beta square, 1 by alpha plus 1 by beta. So how we are going to solve all this, we'll quickly see. See, from the polynomial equation, you can find out the sum alpha plus beta and product alpha beta. Then for any combination you are required to find out, you need to change or modify the combination such that you will get this alpha plus beta and alpha into beta. Example, if suppose you are required to find out 1 by alpha plus 1 by beta, you must convert this equation in such a form that you will have in the numerator alpha plus beta and denominator alpha beta. Nothing, I am just finding out the LCM and adding it, which we'll see in the subsequent problem examples. And one more thing, very importantly, you must understand or know is revise the algebraic identities. So, algebraic identities may have not given much emphasis in class 10, but you have studied in class 9. We'll quickly see what is that. You may not straight away be able to use it. You need to do some rearrangement, but that will help you to solve the problem. So, we'll just look into what is algebraic identities. So, remember, if in your class 9, you would have studied this equation x plus y whole square, x minus y whole square, then x plus y whole cube, x minus y whole cube, and so on. You would have studied these equations in your class 9. So this is exactly what needs to be modified to solve your problems. Example, x plus y whole square is equal to x square plus 2x plus y square. So I am going to rearrange. I am going to hold this and this on the left hand side and push this on the right hand side. The equation becomes this one form. This is one form of the equation. This will help you to find out alpha square plus beta square. So this form will help you to find out alpha square plus beta square. Here this is your alpha plus beta and this is your product alpha beta. Similarly, even x minus y whole square also can be done the same way. X minus y whole square is equal to x square minus 2xy plus y square. And I'm going to rearrange in such a way that x square and y square come together here and substitute whatever I calculated here. So this x square plus y square will be replaced by x plus y whole square minus 2xy. You have another minus 2xy here. So it becomes x plus y whole square minus 4xy. So this is another form of the algebraic identity that you can use to find out, convert it to a form of sum of the zeros, product of the zeros. So alpha minus beta whole square, you can use this equation. Yet there is one more equation based on cubes, x plus y whole cube. I am rearranging such that x cube plus y cube is equal to x plus y whole cube minus 3xy into x plus y. So if you need to find out alpha cube plus beta cube, you straight away need to use this equation. So we are now going to the problems. If alpha and beta are the zeros of the polynomial x square minus 5x plus 6, what is the value of alpha square plus beta square? These were the options. Okay, so now if I, maybe these options could be wrong, but these options could be wrong. I'm not sure. Okay, we'll see. The sum of the zeros from the equation you can find out minus b by a. Remember, I'm not going to repeat whatever I told in the initial pattern. You always need to fit this equation into the standard polynomial form ax square plus bx plus c, because there are times when they interchange these positions and mislead you. So this problem is already in x square plus bx plus c format. So I'm going to apply the formula and find out the value of sum is 5. And now the product alpha beta is c by a, which is 6. But now how do you find out the value of alpha square plus beta square? So here is where you need to use the algebraic identity which we saw in the previous slide. Alpha plus beta whole square is equal to alpha square plus beta square plus 2ab. Whatever you need to find out is here. So you just rearrange the equation. Alpha square plus beta square is equal to alpha plus beta whole square minus 2ab. Okay. Then you know now what is the value of alpha plus beta. Just now you find out alpha plus beta is equal to 5 and alpha beta is equal to 6. So you are going to substitute this alpha beta here as 5 square and alpha beta here as 6. 5 square is 25 minus 12 is 13. So this is the answer for your problem. Now seeing one more example. Maybe if you want, you can just pause it and try it, or we'll see the solution now. So they have given 1 by alpha and 1 by beta. So from the polynomial equation, you need to first find out the sum and product. Sum is alpha plus beta is equal to 5 by 6 minus b by a formula. Then product is c by a, which is 2 by 3, minus 2 by 3. So they have given 1 by alpha plus 1 by beta is what you need to find out. I take the LCM alpha beta, and on addition I get alpha plus beta on the numerator and alpha beta on the denominator, post which you simply need to substitute and get the answer. Minus 5 by 4 is the answer, and here you have it. And I just closed this video with a sample problem. This is very straightforward. You need to find the value of alpha beta plus alpha plus beta plus alpha beta. Find the sum from the equation. Find the product. You need to add it, and you will get the answer as 7 by 5. So in my next video, I'll catch up with some more new patterns of the problems. Till then, bye. Thank you.